Okay, so the last video described the rules. Please make sure you watch that video before you jump to this, okay? Yesterday, some people watched only one video. You got to watch both videos for this to work for you. So these are the odd numbered problems. I believe it's on page 444 and 445. Now, this is not your homework. These are just examples. My advice is watch the example, pause it, do the even number problem. Make sure you write down the original problem and show all your work for credit. So numbers 3 and 5 are the easiest ones. You've got the same base. You've got a quotient. So the rule is to subtract. As long as you know how to do 6 minus 2, you're good to go for number 3. So the answer is 5 to the 4th power. Number 5, if I have 3 to the 9th power divided by 3 to the 5th power, the rule is I subtract the exponents. That's 3 to the 4th power. Number 7, same thing as 3 and 5. Base, same base, raised to a power. You've got a quotient, subtract the exponents. Make sure you have your parentheses. It's negative 4 to the 3rd power. Number 9, oh my goodness, they threw you a curveball. We got a little multiplication up here on the top from 7.1. Remember, I told you have to recall those rules. So first thing we have to do is we have to multiply 10 to the 5th times 10 to the 5th, which is 10 to the, add the exponents, 10th. Now I've got a quotient, subtract the exponents, 10 to the 6th. All right, number 11 is our first quotient raised to a power. So the rule says I'm supposed to take the numerator, raise it to that power, and the denominator and raise it to that power. Okay? 1 to any power is always going to be 1. So you can just do 1 over 3 to the 5th. That will work just fine. If you actually wanted to figure out 3 to the 5th power, I think it's like 243. But if you're grabbing your calculator to do it, I would rather you not use your calculator. These are not designed for you to use a calculator. Number 13. Number 13, there's a couple ways you can do this. The first thing I would notice is that I have a negative raised to an even power. Whenever there's a negative raised to an even power, that's always going to be positive. However, you also could put that negative and rewrite it so it's up in the numerator, like so. Because negative 5/4 is the same thing as negative 5 divided by 4. Remember, we did that with slope. What we're not allowed to do is we're not allowed to give that negative to both. If we do that, it would actually be a positive number. So now I'm just going to raise negative 5 to the 4th power. And then in the denominator, I have 4 to the 4th power. And that's your answer. You're done. Because you're supposed to leave your answer with the exponent rules. All right, number 15. Number 15 is different because you have 7 to the 9th power times a fraction. What am I doing if I have a fraction? Well, first of all, if you want to, you can make this a fraction. And then you're just multiplying across the top. All that really means is 7 to the 9th over 7 squared. So that original problem just means 7 to the 9th times 1, which is 7 to the 9th power, over 7 squared. And of course, then we're just applying our rule, which is to subtract the exponents. What about number 17? 1/3 to the 4th power. So the first rule is I do 1 to the 4th power over 3 to the 4th power, because that's the rule. I'm supposed to take that exponent and give it to the numerator and the denominator. And I'm going to multiply that to 3 to the 12th power, which is a whole number because it's not a fraction. See, there's no fraction bar there, so I can put it over 1 if I want to. 1 to the 4th power, of course, is just 1. And now I've got 3 to the 12th over 3 to the 4th, which is equal to, subtract the exponents, 3 to the 8th power. Beautiful. Number 19, they want to know what is equal or equivalent to this. So whenever you have a problem like this, you're just checking every single one of these. This one here works out to be 16 to the 2nd power because you subtract the exponents. Letter B, you subtract the exponents also. You get 16 to the 10th power. Neither one of those equal 16 to the 6th power, right? This one here, if I do this, I have 16 to the 6th power squared and 16 to the 3rd power squared. And then power to a power means to multiply. and then I would subtract, and boom, that's my answer. That's the one that matches, right? I want to show you that you actually could have done that one also a different way, which would have been easier. Can't I use the quotient rule here first and subtract the exponents? If I do that, then I've got 16 to the third power, because I subtracted the exponents, and then square it. And then power to a power means multiply, and I can get to that answer as well. All right? So a few more and then we'll be done. Number 21 is just like one that we've already done. Y to the 15th times 1 over y to the 8th is y to the 15th over y to the 8th. And then the rule is to subtract. Boom. Quotient raised to a power, just raise a to the 9th power. And y to the 9th power. That's it. Done. Number 25 is just like 23, quotient rule. P to the 4th power, or excuse me, quotient to a power. Q to the 4th power. I don't know why they put letter Q in problems. I hate drawing Q's. There you go. Over here, once again, I said you can take that negative and give it to the numerator if you'd like to. Okay? And you have negative 4 to the 3rd power over x to the 3rd power, because you have a quotient raised to a power. If you want to do negative 4 times negative 4 times negative 4, that would be negative 64 over x cubed. That's good. And then last but not least, you've got these multi-step problems here, 29 through 35. So just take these one step at a time. Make sure you show all your steps, okay? You cannot just jump right to the answer on these. If I have a quotient raised to a power, I take the numerator and raise it to that power, and the denominator and raise it to that power. And now I have to apply the rules that apply to these numerators and denominators here. So I've got a product, 4 times c raised to the 3rd power. That would be 4 to the 3rd, c to the 3rd, and I've got a power to a power over there, which is d to the 6th power. And if you want to, you can take that 4 to the 3rd, and that would be 64. So that would be your final answer for 29. Number 31 is just like number 29. You've got x squared squared in the numerator. The denominator, you have 3y cubed raised to the 2nd power. X squared squared is x to the 4th because you multiply the exponents. In the denominator, I've got 3y cubed, which is a product, 3 times y cubed, which would be 3 squared, and y cubed squared. If you do that, you get x to the 4th over 3 squared is 9, y cubed squared is y to the 6th. Okay? And then multi-step problems here again. Just take them one step at a time. You've got a quotient raised to a power, raise the numerator to that power, raise the denominator to that power. Multiply that times 1 over x squared when you're done. I still have to do this product raised to that power and this product raised to that power. So I've got 3 squared times x cubed squared over 2 squared times y squared. And I'm multiplying that to 1 over x squared. Continuing to simplify, 3 squared is 9. X cubed squared is x to the 6th power. The denominator, I've got 4y squared, or 4 times y squared. And I'm multiplying this to 1 over x squared. So I've got an x squared down here and an x to the 6th up there. If you want to, you can put them into one fraction like that because I'm multiplying them together. And because I'm dividing, I'm going to subtract the exponents. That would be 9x to the 4th over 4y squared. All right. And sorry, it's going to make the video a little bit longer, but I feel like it's necessary to do these longer problems because you might need help seeing them. So we've got 3 divided by 8m to the 5th times m to the 4th divided by n squared cubed. So I've got to do that first. So I'm going to have 3 over, notice how I keep writing the problem down. I'm not doing anything to that. Okay, times. Another common mistake, sometimes people see something like this, 8m to the 5th, and because maybe you're doing it in another problem, sometimes people think that that exponent belongs to the 8. If there's no parentheses around it, that 5 only belongs to the m, not to the 8. So we don't do anything with that. However, I've got an m to the 4th cubed, and over here I've got an n squared cubed. So now I've got 3 times, in my numerator I've got m to the 4th to the 3rd power, that's m to the 12th, over 8m to the 5th n to the 6th. Now what do I have here? One last thing here to simplify. I've got a quotient. Subtract the exponents, you get m to the 7th. Because 12 minus 5 is 7. You still have an 8 and an n to the 6 down there. So I know some of the multi-step problems. I know especially for those people who are like, there's letters, you know, where's my simple math? You know, this is algebra and we need it for algebra 2. So hopefully you followed along with those examples and try your best on your homework. Use these examples to help you and take it step by step. Have a good day.